Hey there. Uh, Filming this a couple days before Super Bowl Sunday. And they say like two really great football teams are playing. I just want you to know that the best football team in the world is actually playing on Saturday. So, American football. What do you guys know? Chiefs. Well, go Chiefs. Whatever. But go Reds tomorrow. How about that? Hey, folks, you've dialed in here to lesson 95, and the title is Combining, which is adding and subtracting, Rational Expressions, which means this involves fractions and no equal sign, with unlike denominators. If you want to see some problems very similar to today's problems, you can go and rewatch lesson 90. Now, we're going to have things that look very much like some of the harder problems from lesson 90, and but maybe a little bit more preliminary work to do today. Let me start off with our basic. We usually start off with something with numbers and just remind ourselves of the rules, and then we'll go to the more abstract things with polynomials and factoring and whatnot. There's some basics on how to add together two fractions that have different denominators. Obviously, we got to find the least common denominator, and then adjust both fractions until we've got them so that we can combine them. We can add them together. So, any questions? I don't know anymore. We would take we would look at this and then say that 3 and 4, the common denominator, ought to be 12. And to adjust it, we could take this one and multiply by 4/4 and this one by 3/3 and get 4/12 and 3/12 equals 7/12. It's pretty standard as far as that goes, but kind of know that the shortcut for these things is if you want to know how the tops should look, you kind of do this little crisscross thing here. Like a 4 goes here and a 3 goes there, and you multiply these two numbers together, and it's kind of the same thing. Okay, so I was like, well, that part ended up being 4, and that part up there ended up being 3 when I just did the previous math, and I get 4 plus 3 is 7, and the bottom part is 3 times 4 is 12, so 7/12 again. I'm gonna I did that just because it's kind of like a shortcut that you're like, let's use the stuff that's already there to skip some of the intermediate steps. We know how to do it with fractions. These are fractions too, but a little bit more complicated. And the key for today is this right over here. What I wouldn't want to do with this is say, here's a factor and here's a factor. Both of these things together, like 4 and 3, must be the least common denominator, or the lowest common denominator that I would put together. And if I did that, I'd have to multiply this one over here by x squared minus 2x minus 15, and this one by x plus 3. But I think we know from experience here that this one right here may have factors, plural, embedded in it, and maybe one of the factors of this polynomial here, when I break it down, well, if it's x plus 3, then I've overdone it by multiplying this side by all this stuff. So I want you to, when you start off, look at all the pieces and see, are any of these factorable? Because there may be clues, there may be structure underneath this polynomial that I can use to simplify my problem. Factor first, factor first. Look at all the numerators and denominators and see if there's any factoring that can be done. And you might see that we just simplified our problem. This is a polynomial. This is quadratic. It probably can break down like this. We look at the negative 15 and we say, the factors that make negative 15, could they sum to negative 2? Right? Negative 15 sum to negative 2. Yes, of course. You got a plus 5 and a minus 3. Multiply together to make negative 15. Sum together. Oops, got that backwards. There we go. Sum together to make negative 2. So my factors are negative 5 and a positive 3. X minus 5, x plus 3. And lo and behold, we replace that with this, and we see that we don't need that whole big thing. We only need the x minus 5 and an x plus 3, okay? So over here, this fraction just needs to pick up an extra x minus 5, top and bottom. That makes our common denominator this. And I'm going to leave it in this factored form rather than foiling it and putting it back as a polynomial, because I'd rather see the individual factors, and then I fix the top. The top gets fixed by multiplying 3 by x minus 5 and then subtracting 9. So here's kind of my updated problem, and I'll just clean the top up a smidge and distribute this here and get 3x minus 15 minus 9 over x minus 5, x plus 3. And then lastly, I will combine these two like terms here, negative 15 and a negative 9, to make negative 24. If I want to, I can even do a little bit more factoring, because I know that 3 and 24 are both divisible by 3, yes? 3x and 24, so I could pull this out and say I'm left with 24 divided by 3 is 8. So if I wanted to, I could leave it like this, but this form is just fine. I'd probably leave the answer like that right there. So factoring first made this not a super duper hard problem. I knew exactly what was needed on this piece right here, and then it's just this distribution and combining with this negative 9 to finish it off. All right. You're like, wait, don't erase that. Just go back 10 seconds. Pause. All right, this one right here, no factoring, no factoring, factoring, and factoring. There we go. Here, hang on, wait, there. Oh, there we go. It's better. Okay, so we're like, what can we do here? It's not a perfect square, so I'm going to divide. This is an even number. It's also divisible by 4. So 196 divided by 4 is, mental math, 99. All right, that's cool. Big. All right, over here. Oh, look, this is factorable. Yes, it is. Yeah. Is that perfect square? That's it. Hang on, it is. You get to experience like what it's like to think through the math here. Take the square root of 196 and I get 14. It's 14 squared. 14 squared. That means this is the difference of two squares. And the squares are 2x squared and 14 squared. So this one sorts out to 2x minus 14, 2x plus 14. See that? See what I just did there? Over yonder, oh, stinky. I can even do better than that. Oh, well, whatever. Yeah, it wasn't even 99. It was 49. Oh, man. Okay, so I could do it this way, but I'm going to get even better. I'm going to split this up and get, that's what it should have been. And so this is x minus 7, x plus 7. It's the difference of two squares. Okay, that's how that factors down. So the problem over here is 2x over 4, x minus 7, x plus 7. I got a little bit of factoring I can do here. I can make this a 1, and I can make this a 2. See how much simplifying I'm doing here? And then this back half here, I got this that can factor out into 8 and 7, and I need a plus 8 and a minus 7. So, I'm going to put this over here because I'm allowed to. I'll go with 12x over x minus 8, x minus 7. Now we look at all this stuff and we've got to collect up all of the denominators so that we have a least common denominator, or lowest common denominator. All the factors here now are 2, an x minus 7, it's in both of them, an x minus 8, and an x plus 7. The first term is missing 2, and it's missing an x plus 7. The second term is missing just an x. I have a 1x there, right? X, and I got, I'm missing an x minus 8. So the bottom's going to stay the way that it is. The top, maybe I can distribute a little bit and clean it up. Basically, I'm 9/10 of the way there to my answer. 2x plus 14 plus x squared minus 8x, a little combining. I'm actually not even going to finish this one off. You can see how it's finished off in the book. I did the hard part there, and now it's just cleaning things up. I'm going to pick maybe one or two more. I'm going to get kind of selective here, but let me clear the board. All right, we're going to move fast. I'm going to try not to make as many mistakes this time. We'll see how this goes. I'm probably not even going to work the whole problem out. You can see how they finish things up in the book. What I want you to do is to think first, what can be factored? What can be factored, okay? And then you got to think about least common denominators and cleaning things up. So we'll start with this one here. Can't factor, can, and can. This is the easy one right here, right? There's a 2 and there's an 8. And so we think divide out the 2, and so that's factored. This dots, difference of 2 squares. This one factors down to x minus 4, x plus 4. You have to be able to see that in order to do this. If you're going to collect the least common denominator, we've got a 2, we've got an x minus 4, and we got an x plus 4. Okay, that's your least common denominator, and then you start adjusting each piece to try to fix this stuff. 2x minus 4, x plus 4. The first one just needs to be multiplied by 2, 12x squared. The second one has a 2 and the x minus 4, and it needs an x plus 4. So we go an x minus 1's already there, and an x plus 4. Clean it up, finish it off. There's going to be some quadraticness here, some squaring, and that one will keep going. Okay, I'm not going to finish that one off. I did the hard part. Not factorable. Not factorable. 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 These are multiples of 9. I take that out, I'm left with x minus 3. This is the difference of 2 squares. X minus 3, x plus 3. We want to collect the least common denominator. We need a 9. We need an x minus 3. We need an x plus 3. First term here needs to be multiplied by x plus 3. Second term here needs to be multiplied by a 9. The rest of it cleans itself up. So I've got 4x squared, x plus 3, minus 9 times 2x minus 5, over 9x minus 3, x plus 3. The top part is cleaning it up. Leave the bottom part, and you're done. One more over here. I'm just going to talk about what needs to get fixed, and then you can finish things up. This one actually has a lot of options. Okay, so you're gonna do what you think you can. This is factorable. This is factorable. 7 and 56. Think, right? 7 times 8 is 56. So if I take out a 7, I got 8 minus x. Or I can take out a negative 7 and flip that around and take out a negative 7, and I've got x minus 8. So options. Here, yeah, this is good. This is a quadratic. I got x minus 8x plus 2. Look, there's minus 8s. That's a better choice. I'm going to choose this one and not choose that one. And then up here, I could, if I wanted to, pull out negative 6 and be left with an x plus 2. So you've got lots of collecting that you can do, but first thing you want to do is to factor. Once you've factored, you can see all the pieces that you have to work with. Here I've got an x minus 8, an x plus 2, and a negative 7. That's my least common denominator. I got to clean up the top and finish it off. If you want to see one or two more, I can help you with that in class, but for now, I think that's enough to get you going.